Hello everyone, myself Pallavi, student of Cambridge Institute of Technology, North Campus. I would like to thank MXC for providing me this opportunity. During this internship, we built project on IoT based home automation. I would also like to thank my project guide Jayalakshmi ma'am for guiding me. And my next slide includes contents that were covered during this internship. And we have learned the concepts C programming and Internet of Things, embedded systems, and also microcontrollers. In first week, we learned about C program. It is a high-level general purpose programming language which is widely used for developing system software. And it is developed by Dennis Ritchie for creating system applications that directly interact with the hardware devices such as drivers, kernels, etc. And this is the structure of a simple C program. It consists of a file header. File header consists of a name of the program and author name, etc. Preprocessor directive. Preprocessor directive trusts the compiler to pre-process the information before the compilation start. The main program. It is a program which is first called by the compiler. Within this curly braces, we place the body of the program, which includes the comment and a simple printf statement. And this is the program termination. Topics also learnt in C. Data types. It is a collection of data, which includes character data type that consists of 1 byte of memory and format specifier is %C. Integer data type that consists of 2 bytes of memory and format specifier is %D. Float data type that consists of 4 bytes of memory and format specifier is %F. Double data type consists of 8 bytes of memory and format specifier is %LF. And modifiers such as short, long, etc. and qualifier. And we also learnt about conditionals. It is a single programming statement which includes if else, else if and switch statements. And loops. It executes the same code multiple times, which includes while loop, for loop, do while loop, etc. And operators, which performs a specific mathematical or logical functions. And we also learnt about arrays. An array is a collection of similar types of data. Pointers, it is a variable which stores the address of another variable. Strings, it is used for storing characters or text. For example, hello world is a string of characters. And we learnt about function. It is a set of statements which perform specific tasks. And also storage classes, preprocessors. My next slide is IoT, which is Internet of Things, which describes the network of physical objects that are embedded with sensors, software, and other technologies for the purpose of connecting and exchanging data with other devices and systems over the internet. IoT, it is a system of interrelated computing devices which enable companies to automate processes and reduce labor cost. Example of IoT includes connected cars, smart appliances, smart agriculture, connected security systems, connected manufacturing equipment, connected retail, etc. And application of IoT includes intelligent home security systems, medical sensors, automotive, industrial automation, and fitness trackers, smartphones, and etc. And my next slide is embedded system. It is a combination of computer hardware and software designed for a specific function. It is a system that has internet connectivity. Embedded system may also function within a larger system. And application of embedded system includes home appliances, office automation, security, aerospace, banking and finance, digital camera, traffic lights, ATMs, and etc. Example of embedded system includes central heating systems, automotive systems, ATMs, medical devices, LED chasers, engineering calculators, DVD players, and etc. And this is a block diagram of embedded system. Embedded system, it is basically a microcontroller or microprocessor based system which is designed to perform a specific task, and also it is a combination of input devices, output devices, and memory. The complexity of the circuit depends upon the objective of the work. It means if operation is complex, then circuit is also more complex. If operation is simple, then circuit will be simple. An embedded system may be individual or part of a large automation system. Project overview. This project is IoT based home automation solutions using Arduino Uno board and PiximLab simulator. We remotely control the device using an app Blink IoT. We automated the garden lights where they brighten according to sunlight. And we also used automated temperature control system. And water tank is automated by controlling the inlet and outlet valve respectively. Objective behind this project is to control all discussed home appliances to Arduino and integrate it with Blink IoT app and the cloud, and to obtain notifications regarding temperature and water tank on Blink IoT, and to check the real-time status of temperature and water level, and to control the garden lights using LDR. Need for home automation. This is the method of regulating house appliances automatically utilizing various control system approaches is known as IoT home automation. If we focus on our daily life schedules, there are many devices which are not monitored as we move to office, colleges, and other places. Thus, to avoid such negligence and also to protect our house from any incident, we can use automation. Various control mechanisms may be used to regulate electrical and electronic equipment in the house, such as windows, refrigerators, fans, kitchen timers, and so on. In the block diagram, the LDR and LM35 sensors and also many sensors that are connected to Arduino Uno through the Blink IoT. We are going to control the devices. Arduino Uno. It is a microcontroller board based on the Atmega 328P. It has 14 digital input or output pins. 6 can be used as pulse width modulated outputs, 6 analog input or output pins, a 16 MHz ceramic resonator, a USB connection, a power jack, and a reset button. Arduino Uno board can be programmed using various IEDs. We used Arduino IED for this project. And PiximLab and Blink IoT app. PiximLab is an open source real-time emulator of development boards with integrated MPLAB-X. It has an integration with Arduino IDE for programming the board's microcontroller. Blink is an IoT platform, iOS or Android smartphones that is used to control Arduino via internet. Blink was designed for the Internet of Things. It controls hardware remotely, and it can also display sensor data, it can store data, visualize it, and do many other cool things. And we created new template device and data streams in the project. LDR, which is light dependent resistors. LDRs are tiny light sensing devices also known as photoresistors. And LDR is a resistor whose resistance changes as the amount of light falling on it. The resistance of the LDR decreases with an increase in light intensity. This property is to use them for making light sensing circuits. The LED lights are connected to the LDR via ADC. The ADC converts the analog input by the LDR into its equivalent digital form, which is converted later by certain formula from 0 to 225 as upper bound. Based on that, we glow the LED. Garden lights control. During the day, the outdoor light is maximum, so the LDR sensor detects the light and the garden light is turned off. Whereas at the night, the outdoor light is very low, so the LDR sensor detects the light and the light is turned on. As we see in the diagram, the LDR sensor detects the light and transfers the information to the Arduino Uno. which in turn controls the light. Temperature sensor. A temperature sensor is an electronic device that measures the temperature of its environment and converts the input data into electronic data to record, monitor, and or signal temperature changes. It is a temperature measuring device having an analog output voltage proportional to the temperature, and it also provides output voltage in degrees Celsius. The sensitivity of the sensor LM35 is 10 millivolts per degree Celsius. This sensor doesn't require any external circuitry to provide accuracy in result. Temperature control system. The purpose of a temperature control system is to maintain a device at a constant temperature. The temperature control system consists of heater LM35 temperature sensor and a cooler. Analog value of temperature is obtained from the temperature sensor LM35 and display it on CLCD after converting it into digital valve using ADC. To control the temperature of the system by turning on or off the heater and cooler through the Blink IoT app. The notification of the same is displayed in the notification bar of the Blink IoT app. Water inlet and outlet valve control. To read the volume of the water in the tank through serial communication and to display it on the CLCD. To control the volume of the water in the tank by controlling the inlet and outlet valve by sending commands through serial communication, and by display the volume of water in tank on CLCD and also on Blink IoT app. The feature is that as soon as the tank is full of inlet valve is turned off, and when the water level in the tank is below 2000 liters, the inlet valve is turned on automatically, and the notification for same is provided on the terminal of the Blink app. As we see in the diagram, heater and cooler both are controlled using Blink IoT app, and the information is passed to the Arduino Uno, which transfers the information to the temperature system, and the cooler and heater is turned on or off based on that. This is a simulation image of my project. As we can see over here, we display the temperature volume, whether the heater is on or off, whether the inflow is on or off. This all is an CLCD. This is an LCD sensor which is used for the internet connection, IoT connection of the app. And this is the temperature of control system, which consists of LM35 temperature sensor. It consists of cooler and it also consists of an inbuilt heater. Serial tank used for demonstration purpose. For water tank, this is the Arduino Uno code. There are connections made. This is the conclusion. Using Blink IoT and PixSimLab simulator, we simulated home automation where LED temperature system serial tank resembles light, heater, cooler and water tank in real time. CLCD acts like a dashboard used for displaying the events. Widgets from Blink IoT app like button widgets are used to control heater, cooler and inlet valve, outlet valve. Gauge widgets to display the temperature and volume of the water. Hence the project provides perfect solution for home automation. This is Arduino IDE where code for home automation is written. Here I have created separate files so it will be easy to maintain. This is the main file of home automation. It consists of Blink authorization. Here we have template ID, template name and authentication token. Here some of the libraries are included to use Blink as well as CLCD. To turn on and off cooler based virtual print and printing notification, the following code is written. Here cooler pin values are read on the virtual pin connected to cooler. If cooler switch is true, cooler is on and this will be printed. If cooler switch is false, cooler is off and this will be printed. Similarly, to turn on and off heater based virtual pin and printing notification, the following code is written. Here heater pin values are read on the virtual pin connected to heater. If heater switch is true, heater is on, this will be printed. If heater switch is false, heater is off and this will be printed. By the following code, here the inlet valve and outlet valve of cereal tank is controlled. We also want to display temperature and water volume on the Blink app, and this is the code for the same where we display the real-time temperature. The following code is written to turn off the heater if heater rises above 35 degrees Celsius. To read temperature and compare with 35 and check if heater is on, this code is written. Here heater temperature is compared with floor 35 and hence heater switch is controlled. And also heater status is printed on the notification bar using the following code. We also need to control the water volume about 2000 liters, hence we create a function called as handle tank. It checks if the volume of the water is less than 2000 liters, then it enables the inlet valve. If tank is full, then the inlet valve is turned off. This is the setup function which is called only one time. Here I have initialized LDR which has garden lights and also initialized LCD and backlight and to clear the screen and to cursor at the first position. Here at the 0th column and 0th row I have printed T, and at 0th column and first row I have printed V, and I also initialized the temperature system and cereal tank. Here we need to get the values for every 0.5 second. So for every half of the second we need to update the temperature on the Blink app. This is the loop function where all the function in it is repeated. Here code is written to control the brightness of LED and to display the temperature and to read the volume of water and to maintain the threshold temperature. Moving on to the next code, this includes the initialization of garden light and also includes the function to control the brightness. Here during the daytime the LED is turned off, or during the evening time or during the night time the brightness of LED is increased. This is LDR header file where we define some macros for LED sensor as well as garden light. This is the main header file where we define macros for on and off and inlet and outlet, and also for cooler and heater, temperature gauge, water volume gauge, and also for Blink terminal pin. Next is the cereal tank file. The cereal tank file consists of a function initializing the cereal tank. Then we define the volume function to get the real-time status of the volume of the function. We define the function to enable and disable the inlet and outlet valve respectively. This is a cereal tank header file. It consists of inlet valve and outlet valve, macros and macros for high float and low float and for volume and to enable and disable. Values of temperature system. Here we initialize temperature system. We need temperature using temperature system using this function. This is cooler control and heater control function respectively. Lastly, this is the temperature system header file where it consists of macros for heater and cooler pins where they are connected to Arduino Uno board, and also for the temperature sensor a macro is defined. This is the Pixim Lab user interface. We are in the spare parts window. Here I have arranged CLCD display. You can see it is displaying the temperature as 27.34, which is normal room temperature. The volume of the cereal tank is currently 3000, which indicates that the tank is full and the inflow is off. This is the LDR system. These are the LEDs garden lights. This is Ethernet used for the internet connection of the Arduino Uno board. And this is the temperature control system. It has inbuilt LM35 sensor. This is the cooler and it has heater. This is the Arduino Uno board through which the different spare parts are connected. And this is the serial tank which is connected to the serial port COM2. We can see the tank is currently full and the inlet valve is off. This is the outlet valve. Now I will pin my phone to the system so we can control these different home automation components using Blink app. Now I have mirrored my phone. This is the Blink IoT app. This is the cooler pin, heater pin, real time temperature reading, and this is the notification bar. There are two tabs, tab 1 and tab 2. Tab 1 is for temperature system and tab 2 is for inlet and outlet valve of the serial water tank. Here volume of the water tank, that is the current volume, is displayed. As you can see, it is 3000 liters. So first we will try to control temperature system now. We will turn on the heater and check whether the temperature is 35 degrees Celsius. Whether the heater will turn off automatically or not, and also check whether we are receiving notification for the same or not. Now I turned on the heater, so you can see that the temperature is increasing. As soon as the temperature reaches 35 degrees Celsius, the heater is turned off. And we have received the notification that the temperature is above 35 degrees Celsius and turned off the heater. Now we will turn on the cooler, and when the cooler is turned on, the temperature decreases and the fan starts rotating and it tries to maintain the normal room temperature. We will turn off the cooler now. Now we will check the cereal tank. You can see that the cereal tank is currently full and the inlet valve is off. Now we will turn on the outlet valve and check when the water level is less than 2000 whether the outlet valve is getting off automatically. Now I turned on the outlet valve and the notification for the same is displayed on CLCD, and the water level is also decreasing. We can see that when the water level is less than 2000 liters, the inlet valve is automatically turned on and tries to maintain the water level. Now the inlet valve is on and it will fill the tank, and when it reaches 3000 liters, it will turn off automatically. Now we can see that the inlet valve is automatically turned off. We will check the notification bar now. When the water level is less than 2000 liters, we have received the notification of turning on the inlet valve. And when the tank is full, we received notification of turning off the inlet valve. Now the last system, that is garden light. This is the LDR sensor. When the sunlight is maximum, the garden light are turned off automatically. And when it is nearly evening or night, the garden lights are automatically increased. So we are getting all requirements. And this is my IoT based home automation project. And thank you.